Okay, section 4 in chapter 21, the Claisen condensation. I've left the aldols, the general aldol reaction up here from section 3. So in the aldol, recall, we get an enolate, and that adds into a neutral aldehyde or ketone. So the thing that really differentiates the aldol from the Claisen is what the electrophile is. All right, so the book sort of talks about the Claisen as if it's always an ester enolate attacking an ester. It doesn't have to be that way, it often is, but so X here, if X here is OR, right, this is just going to be two of the same attack, the enolate of one ester attacking a neutral version of itself. And note the difference. So you end up with carbonyls 1,3 to each other. In the aldol, you end up with a carbonyl and an alcohol 1,3 to each other. So it's change in oxidation state. The electrophile starts off in a higher oxidation state, so it makes sense that the product ends up in a higher oxidation state. So we've talked about how to make enolates. Let's look at now what happens when an enolate attacks an ester. Okay, so we've made our enolate, and again, this could be, you could either do this as a simple version where you've got a weak base that makes a little bit of, right, we could have, OR minus. It's really important here in a Claisen that the base, if you use a weak base, be whatever the ester component is, because it could add in here. Right, so this goes back and forth. ROH would be here, right? So we're going to have an enolate, and then it's going to attack the neutral ester. So you could do that, or you could just do this directly with LDA, right? We could quantitatively make the enolate like we do in the directed aldol, and then add the ester. Either one of those works. So the Claisen, I don't want that to look like it's just with the red. So the Claisen here is a general reaction where we take an enolate and we add it to an ester. So the electrophile is an ester. In the aldol, the electrophile is an aldehyde or a ketone. Okay, so let's go through the mechanism for this. This comes back to when we've added Grignards to carboxylic acid derivatives, you add twice, and that's basically what we get here. So enolate attacks the carbonyl. That makes our carbonyl there, O minus, OR, R prime. Okay. And now this can absolutely reverse. Okay, O minus can kick enolate out, and you just go back to the start. So what drives this reaction is not this first step or even the second step. It's going to be the last step. So you might think, oh, I see how we're going to do this, and you might be, you're onto something. So this O minus in the second step kicks out our O minus. Right? Again, this is an equilibrium process. So and I can almost hear you jumping up and down. That's it. That's the mechanism. We're done. Because look, in fact, you have absolutely made what I told you the product is. So why aren't you done? And the answer is, look at these two compounds. Okay, so this is a 1,3 dicarbonyl compound. Go back if you need to. There's a video on sort of stabilized enolates. So this is a stabilized enolate. The pKa of that proton is about 10. The pKa, the conjugate acid of this, is going to be like 16. And so this acid-base reaction happens. The molecules don't know that that's what you want. They're just going to do whatever makes them stable. So this is like irreversibly to this anion. Not irreversible, but it strongly favors the right. All right, you get this anion, this dicarbonyl anion, very stable. Okay, so, well then what? So the second step of a Claisen is pretty obvious then. You have to protonate. Last step, the negative charge grabs the H. Okay, so This third step drives the equilibrium. Okay, if you don't have this third step, the Claisen doesn't happen. How do we know that? So if you actually have, if you ever try this, if you try a Claisen with no H's here, you don't get any reaction. It just stays at the starting material. Okay, so if we have, let me give you a better example of that. So if we took this compound and tried to do a Claisen, you get no reaction. All right, that's the Claisen. I'm trying to keep these videos short. I'm gonna tell you, if you want, pause, write this down, think about it a little bit. I'm gonna do 2 examples, so you can hit pause, go wander around. This video is gonna be a little bit longer. I'm kind of throwing that in there, so I'm gonna raise the board and do a couple of examples. All right, so hopefully you took a break or your mind is still with us. So here's an example of a Claisen that works really well. Well, there you go. Hit pause and try to predict the product if you can. Okay. So ethoxide is our base, and like I said, you really need to match those parts, right? If this was O-methyl could add in here. And then you'd have some methyl ester and some methyl ester, and you'd get a mixture of products. If this were hydroxide, you'd just hydrolyze the ester. All right, so it's really important that the ester alkoxide part match the sodium or potassium alkoxide part, the base. Okay, now I've got boxes there. Well, anyway, let's go ahead. So this is going to deprotonate here. We're going to get the enolate ethyl propionate, and that's going to add to ethyl propionate. So this is going to be our product, and I'll take you through how we get that. There's the product. Okay, so we deprotonate. And then that adds to a neutral version of itself. Kick out, why do I have R there? R is not R. R is ethyl. Kick out. So there, very transiently, we have what we want. But then it takes the proton from that really acidic position between the carbonyls. This pretty much gives us that anion. I've lopped off a methyl here. All right, and then at the end, so it's not really ever shown here. You'd have to come in here, this would be a step 2, H+. And again, H+ can be, you can work it up with just kind of ammonium chloride, some sort of weak acid, acetic acid, something like this. You can also take this anion and do SN2 chemistry. So like, so this is section 5. Or you can just protonate it and get to it. All right, you can also do this like I said, the enolate doesn't have to be, you can do a directed Claisen. And so LDA we can just go ahead and use ethyl propionate again. And then 3